Alright, I guess we're playing Outpost. What's up, you metamorphs, you sedimentaries, and of course, I can't forget all y'all igneous motherfuckers in there. What is up? Your favorite geologist, Haas, is back. We got Outpost for you. Outpost 207. Ooh, big deal there. We're just going to play some attrition again, but again, we're not going to play. So, I'm going to give you a little talk about mountains this time, okay? And I'm going to talk about how mountains form. I'm going to look in the background, see what I can see for... I guess what I can tell if it was either an extensional regime or a contractional regime, and I'll go ahead and explain those in a second here. So let's see what we got. My team's losing again, big surprise there. Really not too concerned with the score of the game as much as I am concerned with getting back here to these mountains. And we'll see if I can do that without getting shot. My guess is probably not. Well, maybe I was wrong. Okay, so let's take a look here. We're pretty high up in this environment. Really not sure what kind of environment it is. Let's take a look over here. Okay, so from this mountain that I can see so far, and I guess from these ones in the background, all this kind of stuff, this looks like a contractional regime. And what I mean by that is essentially two pieces of the crust came together and smushed each other. And so what happens when you do that is, if you think of, for example, snow piling up. So you have two snow plows coming at each other, and what's that snow going to do when those two snow plows meet? It's going to bunch up into one big mass of snow. And let's see, this is a pretty good example of that right here, this whole line of that, because you can see that crust that was usually nice and flat, and I'll try to move this as flat as I can, crust that was usually nice and flat is now at this angle like this. And that's always a really good indicator that you have had some kind of crustal deformation of that sort. And these mountains over here, just the way that they're shaped, and I'm gonna die because this kid obviously thinks he's fucking amazing. Using a silencer too, what a queer. But that's what happens most of the time, is you're gonna see those really ragged cliffs in that kind of environment. Another pretty good example over here, not as well. Let me see if I can take a gander at what these rocks are. These definitely look like, yeah, these are granites. This is pretty stereotypical granite, and the way I know that is because of the texture. Excuse me, because of the texture of this rock. And now you can see that there's some light and some dark like spots on here, and every granite, well, I should say most granites, will look like this. They'll have these kind of white specks in here, which is one mineral, and then they'll have some darker specks, which is another mineral. And so again, those aren't really indicative of the environment as much as they are just a nice tool to be able to record in the field notes or in whatever things that you're using to take note of. That's a really good peak over there. Doesn't look really real. Usually you don't get something that's that steep. It's kind of not even close to being legit or looking legit or anything like that. I do like this one, using it as an example though. It is sloped the right way. It does look like a real mountain that would have formed. This fucking turret keeps shooting at me. It's still gonna shoot at me. So we're up here above the clouds, so I guess another really good indicator for me that this is a contractional regime is the fact that these mountains are enormous. And a really good example of a contractional regime that we have here on Earth that also is pretty synonymous to what we see in this environment are the Himalayas that are on the borders of Asia and of India. And that environment, those mountains are huge. They're all really jagged peaks like this. They're all really kind of, how do I say this? They're all really blocky and almost unnatural looking in that sense. Oh, I can come out here. Holy shit. Awesome. Haha, can't kill me now. But yeah, that's a really good modern analog of what we see kind of on this map, and it almost looks like a lot of the things that they took from this map were kind of detailed around the Himalayas. Like I said, the scale, the size, we're obviously above a ton of clouds over here. So this is, this is way, way, way high up, yeah. And I mean, we're next to this other planet too. And so this contraction could have something to do with being so close to this other planet, or it could have something to do with this massive spindle space station thingy-majig that I don't even I don't even know what the purpose of this is. Yeah. It's cool. It looks cool. This map is fun just to look at for me, because it does remind me a lot of being really high up in the Himalayas, or being really high up, say, in the Swiss Alps, or some kind of contractional environment like that. And so I'll try to just kind of do these videos on the fly again, like I've been doing. Excuse me, but I've been a little bit sick, and that really does not bode well for doing videos like live, things like that. And hey, what do you know, my team lost. We got embarrassed. No help to me. I have 1 attrition point. There we go. Go me. 1 attrition point, folks. Let's go. Learn it. Yeah. Hope you guys liked the video. Oh, shit. What was my outro that I was supposed to do? Hold on. Let me find it, because I promised Semper I would do this. Let me just see. Outro. Where is it? Oh. So, your favorite geologist signing off here, and guys, remember to stay rocky.